Okay, I think the Aeolian group probably has a harder project to work on than the glacial landforms group because, glacial landforms, water, ooh, that's intrinsically interesting. Why are Aeolian processes, these windborne processes, such an important topic for current day Mars in the Amazonian? What's the major driver of everything on Mars now? It's a windy, dusty, dry planet, right? Okay. So, in terms of what's going on in current day Mars, if you ignore these Aeolian processes, you're missing a big part of what Mars is like today and what Mars is all about. Also, these, as we'll see later, these Aeolian processes, dust and so forth, it's a big driver on climate as we talked about. And so, when we do colonize Mars, we're really going to have to pay attention to dust and wind and these processes that are involved here. Okay, so we're familiar with sand dunes on the Earth. Here are some sand dunes in Vietnam. Here are some sand dunes in Namibia. In Death Valley National Park. So, so we find sand dunes on the Earth where? We don't see a lot of sand dune activity around here. Why not? Why isn't there a lot of sand? I mean, actually, there is a lot of sand. There's a lot of sand. There's a lot of small particles of rock that are the size of sand all around us.
But it's not dry like sand.
It's not dry, and what's holding it all together around here?
Plants.
Okay, we got a lot of plants and vegetation, and again on Mars we don't have that. So just briefly, we've got some different types of sand dunes that can be identified. These Barcan dunes are these very characteristic horned dune structures. You find them where you've got widely spaced actual bedding structures for the dune fields. And in between you would have basically bare ground that doesn't have accumulation of sand on it. But depending on the consistency, the directionality of the wind, the source material, you can have everything from these transverse ridges that just kind of march along the landscape to very complicated structures where sand gets piled up in different directions because of winds coming from different directions at different times. And so the morphology of the dunes can tell you something about the wind regime in the area, which I think was the focus of many of the papers that you guys in the Aeolian group were looking at. Just some basic processes here. Sand dunes form basically by wind blowing sand around. That's why if the sand is stabilized, you're not going to find either dunes being formed, or if they are formed but the sand is stabilized, they're not going to be moving. We talked about vegetation stabilizing the dunes, but also chemical processes. So like salt deposits could cement the sand grains together. Basically have three ways that particles move in the prevailing wind, depending on the size of the particles. If they're large enough, they just kind of roll along the surface of the ground, being blown along. If they are fine dust-like material, they can be carried up into the atmosphere. If they're in between, you get this interesting phenomenon where these intermediate-sized grains get blown up by the wind. They travel kind of ballistically for a while. They hit. When they hit, they might dislodge other particles that get blown by the wind. This is called saltation. How many of you have been at the beach on a windy day and it feels like all these little sandflies are buzzing around your legs because basically you've got these little intermediate-sized sand grains that are saltating or kind of jumping along the dune. You can tell from the dune morphology which direction the winds are going. Basically, you're going to find, in general, a shallower slope on the windward side as the wind scoops up the sand. And then as that wind and sand rises over the crest, basically the sand grains get dropped down on the far side. So if you need to climb a sand dune, you want to climb up on which side? Climb up on the windward side, you can make it to the top. At the leeward side, basically the sand is barely stable. I mean, any kind of disruption, and you're going to find sand cascading down because it's piled up as steeply as the sand grains can support. Okay. So if you try to walk up the leeward side of a sand dune, all you're going to do is basically cause these cascading flows of sand down. Again, I mentioned these bark and dune formations before. These are, you can get some very spectacular bark and dunes. Some of the dune fields in like the Sahara Desert, in the areas where you do get this kind of morphology, these can be hundreds of feet high. And so, Lawrence of Arabia kind of scenery. In the case of these bark and dunes, these kind of horn structures point out very clearly what direction the winds are blowing. So we have, of course, seen dune structures on Mars extensively, both from orbit. So here is, I think this is a high-rise image from Mars Reconnaissance Orbiter, where they were looking for the Opportunity rover, and when it came up to Victoria crater. But you can see here in the center of the crater these different kind of dune patterns, and it's a little pixelated blowing it up like this. But what do you see in terms of orientation of the bedding fields and so forth? We're talking about sand and dust, and now everybody's sneezing. Yeah, Stacy.
I don't know weird how it all came together. It has more space to spread, but it all just crumbled up.
Okay, so that's an observation. We see these dune structures toward the center of the crater. They're not as prominent around the outside of the crater. Why might that be?
The walls of the crater would prevent them from forming because they would provide a wind block, and also because maybe they're too steep for sand to form.
Okay, well, the walls of the crater certainly are involved here. But what's going to happen as the wind blows across the landscape and down into this crater? We'll oftentimes see some, different kinds of vortexing of the wind as it comes down around that side. Basically, my guess, and I haven't looked at Victoria Crater in detail here, is that you're going to have the winds kind of scouring the loose sand to a greater extent around the edges of the crater because of these vortex wind flows and so forth. And that's going to result in more of the sand, loose sand, being piled up in the center of the crater. And these are not simple Barken dunes. They're not simple transverse ridges. You can see that we've got some dune fronts that appear to be along this direction, but we've got others that are at kind of right angles. So this really shows you in detail kind of the complex wind patterns that you find inside the crater here, and how that results in how that influences how the dune fields are showing up. This is just what it looks like from ground level. A picture from the Opportunity rover, again showing those complex dune formations in the center of Victoria Crater. Here is here's a picture of an old river channel that's recently been uncovered by erosion. And where do we see dune field activity in this channel? Oops. And so we've got some dunes that are showing up here. We've got some dunes here. We've got some dunes here. How does the orientation of these dunes relate to the morphology of the channel?
It's above, right? Or am I, or is it in the channel?
These are in the channel. Well, there's a large channel. So all of this is a large channel. And then, of course, there's a smaller channel here that's been cut later in the larger channel. But, these transverse ridges here indicate that the sand is traveling along the length of the channel. There are some data showing that at least some of these dune fields are active. It's pretty subtle, but if you have the ability to take, for example, high-rise pictures of the same area separated by years, you can see that the sand is actually moving. In some cases, it's not moving in other cases. We see a lot of dunes in the polar regions. Again, these are sort of like Barken dunes. Here, more complex dune patterns here. Which direction do you think the wind is blowing for this picture? How many say to the right? How many say from the right? From the right? Okay, yeah. So we're essentially having prevailing winds in this direction. And although these aren't widely separated, you can sort of see that morphology of this dune migrating along this way. Here is a more striking example of these Barken dune formations. As we get better and better cameras, we can see finer and finer details, and so currently there's a lot of interest in these transverse aeolian ridges, which is why we had so many papers on them. These are intermediate in size between actual ripples and the larger sand dunes. And many of these are not moving, although some of them may be. Here's just here's a combination of two different kinds of wind-blown morphologies. These long linear structures that are eroded and eroded in parallel with the direction of the prevailing wind are called yardangs. So, like we talked about, there's not a lot of rain, there's no rain, so there's not a lot of water erosion on Mars today. And so what we basically have is wind blowing for millions and hundreds of millions and billions of years on Mars, basically scraping and scouring the landscape. If you look closely, though, there are these transverse aeolian ridges filling up the spaces between the yardangs. So here's the uneroded structure, the yardang, and the loose sediment being modified and blown in between. And that's just a pretty dune picture.